Dear students, hope everyone is doing fine. Now, since the midterm examinations are over, we have to continue further. So, we'll be starting with the third unit, that is software designing. And today, we will be discussing about the basic concepts of software design. But prior to that, we will be looking at what we have done till far, that is software development life cycle, which consists of 7 phases. We have done all the traditional models like waterfall model, prototype, iterative model, evolutionary model, and spiral model. After that, we discussed rapid application development model, rational unified process model, agile software development, which includes two methods, that is extreme programming and Scrum. Thereafter, we did software engineering process, which includes elicitation, analysis, specification, validation, and management. Further, we prepared an SRS document and discussed the template for the same. Along with this, we also discussed the analysis tools which are a part of requirements as well as designing. The first tool that we did was data flow diagram, data dictionary, decision tree, and decision table. To continue further, now we will be looking at what a software designing is and what are the activities that are being carried out. Software designing is just a plan, a planning for a solution what we have already identified in the requirement phase. So it says it deals with the transforming the customer's requirement as described in the SRS document into a form that is suitable for implementation in a programming language. It simply says that designing acts as an intermediary step between the requirements and the coding. Now, the items that are being identified during the design phase. If you remember the module dependency graph, just correlate with this. The first step is we need to identify the modules which helps in the design solution. After identifying the modules, we identify the control relationship between those modules, whether it is a calling relationship or call by relationship. Then we identify the interfaces among these modules. Interface means is the data that is being exchanged between the modules. Then we look forward for the data structures of the individual modules, how to implement them, which all data structures will be required for their implementation, and all. Finally, we prepare the algorithm, that is the steps required to implement the solution. So these are the basic activities that we need to identify during the designing. When we are talking about the design, by default we mean is function-oriented approach. Right? We have two approaches for designing, the function-oriented and object-oriented. So as of now, we are taking care of function-oriented approach. So according to function-oriented approach, we have two types of design. The first one is a preliminary design or a high-level design, and the second one is a detailed design or call it as low-level design. High-level design means identification of the modules and the control relationship between them, right? What are the input and the output formats required? We prepare data flow diagram and structured chart during this phase. Detailed designing is identifying the details of whatever we have identified earlier, the data structures, as well as the algorithm needs to be prepared here. We prepare a document here that is known as module specification document that lists all the modules and the detailed specification. Now, a design should have certain characteristics, right, which makes it a good design, good to implement. The first and the foremost important thing is the correctness. Whatever designing we are making, that should be correct. That means it must be in sync with the requirements present in the SRS document. The second important characteristic is understandability. A good design must always be understandable. If the design is not understandable, coders will not be able to implement it, testers will not be able to test it, Maintainers will not be able to maintain the code. So, in software, what is important is understandability. Each and every concept, whether it is your requirements, whether it is your designing, whether it is your code, or whatever task we do, whether phase related or non phase related, it must be understandable in nature. The third important characteristic is efficiency. Whatever we are preparing, the design, it must give you an optimized solution. There are n number of designs that can be prepared for a given problem. So we have to look for the design which gives you an effective result or an efficient outcome. And the fourth characteristic that is important is maintainability. We know that now and then changes will come. Changes are inevitable in nature, even during the development or once the software is deployed. It is in the operational phase. Anytime we need to maintain the software because changes will definitely come. So there must be scope in our software to make the relevant changes. Now, understandability. Understandability of a design is a major issue. Why? Because it determines the goodness of a design. If it is understandable, we'll say it is a good design. If the design is proper but not understandable, then it's of no use. So the first thing is it determines the goodness of a design. A design that is easy to understand, also easy to maintain and change. That is understandability. If the design is not understandable, what will be the impact? The effort required to maintain will be more, right? And we know that the maintenance cost is roughly 60% of the overall software cost. So, in order to reduce that cost and the effort and the cost, we try to make the design, the code, and everything more understandable in nature in order to facilitate understandability. Now, what shall we do exactly? How the design can be made understandable? The first thing, using consistent and meaningful names. Whenever we prepare a design, we must name all the process or the data flows or the data stores which represents the name or the meaning, right? Design solution should consist of a cleanly decomposed set of modules. Now, what does it mean? We know that whenever we have a large and a complex problem, we develop a software. Now, in order to implement that large and a complex problem, we divide it into subparts, further into subparts, until unless we get the smallest submodule which can be easily implemented. The basic advantage is the things which are in smaller in size or less complex that can be easily understandable and implementable in nature. The same is the concept applicable here. The design, when we are going to decompose our design into modules and submodules, it must be cleanly decomposed. The process is known as modularity. Clean decomposition we'll discuss further in the next few slides. Once we divide this into modules, we arrange these modules in the form of a tree-like diagram. Right? Tree-like means the major module at the top or the root, then the submodules, further the submodules, so that arrangement must be proper in nature. Now, what leads to cleanly decomposition or the neat arrangement? Let's see. First of all, the basic concept is modularity. So everyone knows what is modularity? Decomposition of a problem cleanly into modules. That means the problem has to be decomposed into modules and the submodules. The modules must be independent in nature. Independent in the sense they must have minimum correlation with any other module. Negligible is not possible. Yes, they are going to share some interfaces, but it should be least in number. And we follow divide and conquer principle. We divide the problem into submodules, modules, submodules, likewise, and then we keep on implementing them one by one, and lastly we integrate them together to get the overall design. Right? Second concept, module independence. We were talking about There must be least interaction between the modules. Why least interaction? Because if we want to understand the design and it has number of interfaces, say 10 interfaces shared between two modules M1 and M2. So in order to understand M1, we must know M2 because it is sharing 10 parameters, right? So we say if the number of parameters are less, then it becomes easy. Just to understand M1, we just have to take care of one interface, understand M2 and then back to M1. So it becomes easy. So modules can be understood separately. The complexity reduces, yes. Remember that it is very difficult, like the same example. The bunch of sticks, if we try to break together, it is a very tough job. But once you untag all those bunch of sticks and give it to an individual person, it can be broken down easily. Same is the modularity. Large and complex problem cannot be solved at one go. It becomes complex. So we divide it into modules and submodules and we can easily explore and implement them. So now, what is a clean decomposition? Clean decomposition, the first structure that is represented here is a cleanly decomposed set of modules. Like this is one of the root module which is decomposed into two, further decomposed into three submodules. So we can see the flow. The top module is known as superordinate module, while the lower ones are known as subordinate modules. So clean decomposition means there must be like superordinate module can call a subordinate module, not vice versa. First thing. Secondly, the modules at the same level can never call each other. Third, the module at the root cannot directly go and invoke a module at the lowermost layer, skipping the intermediate layers, right? That much it states that a layer 1, say if it is layer 1, layer 2 and layer 3. So the module in layer 1 can only call the modules present at layer 2. Layer 2 modules can only call the modules present in layer 3, right? They cannot skip, they cannot call in the backward direction. You can compare it with the second figure where the invocation is like you can see to and fro at the same level, reverse, or maybe this also. So we must have a cleanly decomposed to make it understandable. It is clear from the figure itself. Now, neat arrangement of the modules. What are the parameters that leads to neat arrangement? So the few of the parameters are fan out, abstraction, depth, width, fan out. Right? So what are these? What is a fan out? Fan out is, let's talk about from the previous slide, fan out. How many modules are being called by a given module? Say at this layer fan out is 2 for this. If we talk about these two layers, fan out is 3. 3 modules are being invoked by this module. So what do you think? Fan out should be less or more? It should always be low because the number of modules which are being invoked by a given module, it should be less because if it is more, what will happen? The number of parameters will be more. Say अगर ये 10 modules are these, so minimum of 10 parameters will be shared. Now to understand this modules, you have to understand all these 10. Right? So it should be less. Similarly, we have one more concept that is fan in. Fan in is number of modules calling a given module, right? Say let's assume I take this figure is sufficient. This is fan in when two modules are calling a given module. Fan in, that means a number of modules invoking a single module. It should be high or low? It should be high or low. It it should be high. Why high? If there are more number of modules which are calling a given module, that means it is called here also, here also, here also. That means the concept of reusability is achieved here. And we know that reusability is a very good concept in software engineering. Why to implement a module again and again which is required at different places? Once you make it and call it at different locations. So this is what fan in is. It should always be high. What is abstraction? Abstraction is it must be arranged in layers. To have a neat arrangement, like we have seen in the example, this is abstraction. Layer 1, layer 2, layer 3. Depth, the number of levels of control. That means the number of levels that needs to be achieved. Width, overall span of control. That means one module is controlling how many modules. That is width. Okay. Fan out we have already done. Fan in we have seen it. So fan in is represent code reuse and in general it is encouraged. We must always have high fan in. So thank you for today.